Next one. Very similar to what we just saw. However, it now has a negative charge. So let's go over that. There are lone pairs here. And then note that sometimes you won't actually be given the lone pairs that are there. So sometimes you could just see that it's a negative charge, and you had to know there are lone pairs there.
Oh, on that carbon, okay.
Yes. Okay. And this again goes back to our bonding patterns, just seeing the different types of carbons. So we already went over the positive charge, which was a carbocation. Now this is a carbanion. Just because I know, okay, there are 3 bonds here, there's a hydrogen that's not being shown. I also know that there are lone pairs and a negative charge.
Okay.
What would be our first resonance structure? How would the electrons move?
So I could move, let's see. Could I move? I know I can work with the lone pair and then the pi bond, but this, like these ones right here are all sp3s.
Correct. We don't touch that at all.
Okay, so I wouldn't be able to move anything. So
No.
I'd just be able to like swap that right there.
So think of it as I can only have electrons moving this carbon, this carbon, this carbon, because these are the carbons that are involved in that double bond or that pi bond.
Right.
This is the carbon that has a lone pair, and again, it's pi bonds, charges, lone pairs.
Yeah.
But we're not. Nothing's going to move here, here, and here.
Okay. So could I then move the arrow? Well, can I move the lone pairs down to this side right here and make like a double bond?
You're good. So you're saying moving this. Actually, let me see if I have another one. I'm going to do it this way. Moving this guy here. So if we moved these electrons to then make a double bond.
Oh, that was cool. Okay. I didn't see that. I was like, wow. Magic.
Thank you. Now what do we have to do?
You'd have to change. Let's see.
I might do the same thing for. Hold on, let me replace this. More magic.
So, I know that the charge has to move
Yes.
because now there's 4.
Yeah, because
like four
now
bonds.
this is neutral. Yes.
Right. So now it's like evened out. But the charge now would be. I don't know.
So we're not done moving things.
Oh.
So this moved this over, which is fine. But now where did those other electrons want to go?
Right.
So this moved here. We can have multiple arrows. And a lot of times negative charges will have multiple resonance arrows being shown.
Okay.
So then now we said that the only places that electrons can move was this carbon, this carbon, and this carbon. So what if this one can now
became
move?
a lone pair.
Yes, beautiful.
And then that would have a
yes,
charge.
so then that moves to this carbon. So then now I know,
Little magic.
yes, that now moves here.
And then I keep my charges.
Yes.
Okay. So that'd be the only one I could do, right? That would
That's
be
the only thing.
resonance structure.
That's the only thing you can do. We cannot continue to move anything
there.
around
Yeah.
because this would just go backwards, right? If I would then move back here,
And then have the same.
I'd have the same exact structure, yes.
Okay. That
Cool.
makes sense.
So let's draw this one, and I'll have this one here.
So I'd move this little. Oh shoot. Okay, wait. It was this little arrow to that part right
You're
there.
good.
And then this right here. Do I have to like? Does it matter how or where I point
It doesn't matter where, as long as the head of the arrow points to that point.
To that point. Okay. I'll just go like this.
That's fine. That's fine. I know it's not perfect. And you could have gone this way. You could have gone inside.
Okay.
As long as it's clear where it's starting and where it's ending.
Okay.
And then same thing here. That's totally fine. I can clearly see that it is the lone pair. You could have even gone there.
Okay.
Another thing is if this was just a negative charge. Some professors will be fine with you pointing it just at the negative charge, while others want you to draw on the lone pair and show the lone pair.
Oh.
So that is dependent on your professor.
Interesting. Okay, that's good to know. So then I do this little guy. And this would move to right there.
Good.
And then that
Scooch
one.
this over.
Oh, thank you. Would move this right here.
That's it.
Nice.
And it is always important to double check your charges. You already have that down, which is great. Another way to remember this was formal charges, was knowing that this carbon, and actually even knowing what it even looks like, right? The carbanion. But that is something that can help you, just knowing the formal charge of everything. This became neutral. This is now where the negative is. The negative doesn't just magically go away in this case.
Right, okay.
So if you like this practice problem and want to try another one, click right here. And if you want to watch the entire study session, click right here.